Okay.
So yeah.
Okay. So let's move this even further
Okay.
by doing the maximum and minimum speed
Okay.
a car of a certain weight can go.
Okay.
Um,
So you want to know the maximum and minimum that it can go without sliding, or what? What's
yeah. It says, what is the maximum speed a car of 1,200 kilograms can round a turn a radius of 87 meters
Okay.
on a flat road? And then if the coefficient of static friction between tires is 0.45.
Static friction?
Yes.
Okay. Okay. Just gonna move some. Okay, so this is what we have, and it wants to know. Right?
Yes.
Okay. So what do you think? Like, how should we start this problem?
Draw a diagram.
Okay. So we got something similar to last time, right? So we have like a curve. Is that what it's saying? It's going around a curve, right?
Mm-hmm.
So here's our car. Velocity. So what else do we know about it?
We know the radius.
Okay. Yep. So we got a radius, which is 87 meters. Okay. What about like forces on the car?
We know the static friction force.
Mm-hmm. Yep. So we're gonna have friction, right?
Yeah.
And then what about like the turning force, or like, so we got centripetal force too,
Centripetal
right?
force,
Mhm.
right?
Yep. So we got centripetal force.
Oh, going. That's right. Equal opposite.
Yep. Yeah.
Okay. Okay. Cool.
Yeah. So let's do so for V max, how would we get that? Well, I guess first of all, since this is static, what do we know about these two forces then?
They equal each other.
Yeah. So we could do the whole thing we did last time, right? Like break it down. So we're gonna end up with this. Yeah.
Okay.
And so this situation is for like V max, basically. So I mean it'll be true for the other one too, but like pretty much so as long as this is true, the car won't slide. So as long as this force is greater than the frictional force, then we're good.
Okay.
And if this ends up being true, so as soon as the frictional force, as soon as that gets bigger, like greater than this, then that's where we're going to slide out.
Right.
Yeah.
I mean that makes sense.
Yeah.
Okay. So what's the equation we should start out by using?
Okay, so the equation we should start off with using is I would take these, let's put them over here again, and I would break these down.
Oh, okay. So you take what you have. So this is the steps that you would use in doing this.
Mm-hmm.
Okay.
Yeah. So I would break this one down to say like, right, and then this one's going to be, yeah.
So friction equals static friction times normal force.
Yep.
So normal force is pushing against the mass acceleration.
Yeah, so normal force is actually going like up.
Up.
Yeah. So if you look at this car from like a sideways point of view, so this is like bird's eye. If you look at it from sideways, you have like, so coming towards us would be like friction or something, right?
Yeah.
So we're looking at, if we like tilt it down, the camera down, I guess, friction's gonna be like coming towards us, and then, so it's going around the turn, right? It's like kind of going like this.
Yes. Yes.
And then, so yeah, so we have normal force, and gravity right there. Yeah. Let me just put this in. Yeah.
Oh, force, normal force plus the static friction of the tires on the road
Yeah,
is keeping it from going into the circle.
right.
Which is that hard. I get you. Okay.
Mhm.
I see.
Yeah. So, yeah, exactly. So this is our normal force, right? So that's going to be equal to mg.
Yes.
And that's pretty much always true as long as the thing's not moving up or down. And as long as there's not like any other forces acting on it in the direction.
Okay.
If that like, so if something were like pushing this car down to make it seem like gravity was bigger, the normal force would increase. But in this case, just this is true. Yeah, so then we can break it down again. So we're gonna say, right, and then we got our static here, and then mass times gravity.
Okay, that makes sense.
Yep. And so that is gonna be, let's see here. Yeah, that'll be this situation.
And that'll be the max.
Yeah.
Yeah, okay. And then just put all the numbers in, get it.
Yep. Yeah. And the other situation would be where basically there's going to be like no friction acting on it. So it's like turning in such a way that like it's going really slow. So basically like friction doesn't have to pull it, if that makes sense.
Mm-hmm.
So you'll just have just this force. And then, let's see. I think you can just solve for that. Oh, we don't know what this is. Did you go through this one and solve it before?
Yeah. Yeah. Didn't make sense to me as I was doing it? No. It's just because of the motions.
Yeah. Yeah, so that's how you get the max. I think the minimum you just do this one then. No, how do you get that one?
The minimum isn't on this equation. I was just questioning.
Oh, gotcha.
He said in class, so like we'll never want to do minimum because why would you ever want to go to minimum speed?
Yeah. Yeah, you don't really deal with it, but I think you would just do something like this for friction 0. But I think it'd have to give you this value. Because or else you can't, there's 2 unknowns and then.
So,
but yeah, that's how you do maximum.
I get how you, so FR comes down on the left side.
Yeah.
And then the frictional force on the right side, you turned it from mg to mar?
Yeah. So this to this.
Oh, right there.
Yeah. So basically, I'm just saying, using this equation, right? And then just substituting that in for there. And then substituting the normal force in for this.
Okay.
Does that kind of make sense?
So the the force of frictional force translates to m times a. Oh,
this is
static friction.
Yeah, this is supposed to be. Sorry.
Right,
it's hard to draw.
Right.
Yeah.
I saw that was at AU.
Oh, gotcha.
But how did you go from the static friction mg to mass times?
Oh,
a?
this?
Yeah.
Oh, this is separate.
Okay.
Sorry. This is just my thoughts for minimum. This one is for max, and then.
Okay.
So that's the equation used, and then from there, so you can just ignore that bottom part.
Okay.
So does that make sense? How I went from here
that does.
to here to here?
Okay,
cool.
I get that.
Okay,
yeah.
cool. So now, we can just solve for v squared.
Mm-hmm.
Yeah.
Mm-hmm. Okay. Yep. Okay, cool.